Alright, in this video we're going to cover the DMA 80 review for the final. 25 questions, and let's go ahead and get started. Number one, find the square root. Assume that all variables represent positive real numbers. Since the variables represent positive real numbers, we don't have to worry about any absolute values if we were taking even roots. So straight to the problem, the square root of 16x to the 12th. That is going to be equal to 4x to the 6th. And we don't have a square root left over. But just in case you're a little rough around the edges with remembering how to take the square roots of numbers and variables, remember you can break these numbers up. 16 we can break up into 4 times 4, just in case you didn't know the square root of 16 was 4. And then the 4's we can break up into 2's. And remember, for the square root, you're looking for pairs of numbers. So there's a pair of 2's and there's a pair of 2's. And every time we pull a pair out, we're going to write it down one time. So there's a pair of 2's, we write it down one time. There's a pair of 2's, we write it down one time. And 2 times 2 gives you the 4. X to the 12th. Doing this the long way real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you have x to the 12th, that means x times x times x, and you do this 12 times. How many pairs can you pull out? 1, 2, 3, 4, 5, 6 pairs. And notice we don't have anything left to put back inside of the house. That's why there is no square root left over. But remember the shortcut here, the square root of 16 is 4. And then just ask yourself how many times 2 can go into 12. That would be 6 times. Now the second problem, we want to approximate, use the calculator to approximate the square root to 3 decimal places. Check to see that the approximation is reasonable. So go into the calculator for this one. And we want to find the square root of 480. So there's no need to simplify this because it says use the calculator to approximate it. So the square root of 480. And doing this to 3 decimal places, so we have 21.909 because that 9 will tell that third decimal place to go up to the next digit. So 21.909 is going to be our answer. I'm putting the approximate. And it does say check to see that the answer is reasonable. It's just a way of checking your work. If we go back to the calculator and do 21.909 times 21.909, if we take, another 9. If we take 21.909 and multiply it times itself, notice we get something that's pretty doggone close to 480. So that is a good approximation. And on to number 3. The cube root of negative 8x to the 24th y to the 36. Now for the negative 8, I will break it up, and recall, since that's a negative 8, we have negative 2 times negative 2 times negative 2. We're looking for groups of 3, so therefore the cube root of negative 8 will be negative 2. Remember, every time you pull a group out, and we're looking for groups of 3, you write it down one time. Now, do not waste your time and write down 24x's and 36y's like I did back in number 1. You want to ask yourself, how many times does 3 go into 24? Therefore, we can pull out 8 groups of x's because 24 divided by 3 is 8. And doing the same thing with the 36. 36 divided by 3, we can pull out 12 groups of y's. And that's our final answer to number 3. On to number 4. All right, assume that all variables represent any real number. Now, with that written there, since it says it's not necessarily a positive real number, we'd have to be careful. But since we don't have any variables, we really have nothing to worry about. But I did mention that in class. The fifth root of negative 10 to the 5th. There's several ways you can do this. Negative 10 to the 5th is going to be negative 10 times negative 10 times negative 10 times negative 10 times negative 10. Looking for groups of 5. As you can see right here, we have one group of negative 10s. Therefore, the fifth root of negative 10 to the 5th is negative 10. But what you could do here as well, and you could have done this in the last example too, you could go ahead and convert these to rational exponents. We could write this as negative 10 to the 5 over 5 power. And negative 10 to the 5 over 5 power is negative 10 to the first power, which is still negative 10. So either way you look at that, you can still get that same answer right there. On to number 5, let's evaluate. If f of x is equal to the cube root of x minus 31, find the value of f of 4. So what we want to do here is we want to find value of f of 4 by plugging in 4 to wherever we see an x. So we have an x there, we're going to write a 4 instead of an x, and then we subtract 31, and let's see what we get. 4 minus 31, really what we have here is the cube root of negative 27, and either you can go to the calculator or, this is a nice cube root. Negative 27 is negative 3 times negative 3 times negative 3, therefore we can pull out a group of negative 3's. So the cube root of negative 27 is negative 3. And all we did there was plug 4 into x to get that negative 27. On to number 6. Use radical notation to write the expression simplify if possible. So recall, if we have x to the a over b power, that's the same thing as taking the b root of x to the a power. So to do that, we can either go straight to radical notation right now, and I'll tell you what, I'll go ahead and do that, and I'll come back and show you another way as well. What we really have here is this stuff right here goes on the inside of the radical. All this stuff right here we can think of as being that x right there. So let's put all that inside of a house. And it's the 12th, not the 1/2, so it's x to the 12th power. I'm just writing all that stuff inside of a house. The denominator of the exponent, the b in this case, is going to be the index of the radical, so we have a cube root based on that denominator. And all this stuff inside of here, there's no need to really put this, but you can raise it to the first power based on that 1 right there. Notice the numerator, a, is going to be the power that all of that stuff on the inside of the house is raised to. But like I said, there's no need to even really worry about that. From here, we can go ahead and simplify this. So the cube root of 343, is that a nice number? I think it is. It's 7. But now be careful, if you take negative 7 times negative 7 times negative 7, that's what gives you negative 343. So there's our group of negative 7's. And then how many times does 3 go into 12? It goes into 12 4 times, so we can pull out 4 groups of x's. And that's our final answer there. Now we did convert to radical notation, but notice we don't have any radicals left over. What you could have done right off the bat, since we don't have any radicals left over, you could have looked at it like this. Negative 343, that's understood to be to the first power, and then we have x to the 12th power, and this is all raised to the 1/3. Since all this stuff inside of here is one term, you can multiply these exponents. So really what we have here is negative 343 to the 1/3 power. And then if you take 1/3 of 12, you get x to the 4th. If you take 12 times 1/3, multiply those together, you get x to the 4th. Notice that pops up in our answer. Now, like I said, we did get a nice number here. No crazy decimals or anything like that. And go to the calculator and notice we will also get that here as well. Take negative 343 and raise it to the 1/3 power. Now be careful with your parentheses here on this particular calculator. I got the negative 343 in parentheses, and then I have the 1/3 in parentheses for the exponent as well. And notice we do get negative 7, and that's exactly what our answer was right here. So just showing you an alternative method for that problem. Now number 7, however, we must use this right here. So keep in mind the denominator is going to be the index, and then the numerator of that exponent is going to go on the inside of the house, or I have mentioned another way of writing that as well. What we'll go ahead and do is we'll write it like this. This is totally fine. Remember, the denominator is the index, so we have the 9th root. And then the numerator goes on the inside, so we have 3x plus 2, but remember to raise all of this to the second power. I'm totally fine with you writing it like this, but I've also mentioned that you could write it like this as well. The ninth root of 3x plus 2, and then you can take the entire thing and raise it to the second power. Either way you want to do it, I'm okay with it. Sometimes one is easier to simplify than the other. It does say simplify if possible, but we can't pull out any groups of 9 because all we have is 2 groups of 3x plus 2 inside of here, so we don't have enough to pull out a group of 9s. All right, on to number 8. Write with positive exponents, simplify if possible. So since we have this negative exponent at the bottom, if we shoot this up to the top and its base, we make it positive. So we have a 1 up top already up there times x to the positive 8/9. And 1 times anything is itself, so the 1's not really too important. Therefore, our final answer is going to be x to the 8/9 power. There's nothing to do to simplify this here. We don't have to write it in radical notation. The fraction does not simplify, so we're totally done with that problem. Number 9, use properties of exponents to simplify the expression. Write with positive exponents. So here, since we have like bases and we're trying to multiply these like bases, you want to add your exponents. That's the property of the exponents that we want to use here. So we have z to the negative 2/5 plus 3/5. Lucky us, we do have common denominators, and we have to have common denominators when we add fractions. So negative 2/5 plus 3/5, we get z to the 1/5 power. Just review your idea or your properties of multiplying fractions, common denominators, and you just add those numerators together. That's how I got that 1/5. All right, number 10, 2 properties that we need to look at here. First of all, we have 1 term inside of this thing, so I'm going to take negative 2 and raise it to the first power. Then we have x to the 3/5. Since all of this stuff is 1 term, we can multiply these exponents. Therefore, we have negative 2 to the 5th power, because we took 5 times 1. And then if we take 3/5 times 5, we can multiply these two as well. 3/5 times 5 over 1, the 5's cancel out, so really what you have here is 3 over 1, which is just 3. So we can write this as x to the 3rd power. All I did there was take 3/5 times 5 using the properties of exponents. When you have powers raised to another power, you can multiply these exponents, as long as you have 1 term on the inside of the parentheses. Now at the bottom for right now, we'll leave this alone. So we have x to the negative 3/5. And then from here, let's simplify this some more. So negative 2 to the 5th power. What you're doing there is you're taking negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Therefore, you get negative 32. That is simplified for that part right there. Just be careful with your signs. We still have x cubed up top, and at the bottom, we have x to the negative 3/5. Now it says write with positive exponents, so we need to shoot this thing right here up to the top. Therefore, we now have negative 32, x to the 3rd power, and then we now have this x to the positive 3/5 power. Don't worry about a denominator because we moved that entire piece up to the top. Now the problem here is that you need to add these as well because we have like bases and we're trying to multiply these like bases. And when you do that, you need to add these exponents, kind of like what we did right here. However, I'm just going to go ahead and rewrite 3 as 15 divided by 5. And then this 3/5, I'm going to leave it alone. Notice what I did here is I got common denominators. That 3 had a denominator of 1, so that wasn't too helpful. So 15 divided by 5 is 3, and now notice we do have common denominators. So our final answer, we have negative 32. And then when we add these two exponents right here together, we get 18/5. So we have x to the 18/5 power. And you can leave it just like that. We don't have to convert to radical notation or anything like that. So we're good, just as long as we have positive exponents. Now, you might say, well, 5 goes into 18, but we don't have to convert this to radical expressions, and we don't have to write this. By all means, please do not write that as a mixed number. Leave it alone. All right, on to number 11. Use rational exponents to simplify the following. So now we're going backwards. Remember, the number on the inside is your numerator, the number on the outside is your denominator. So therefore, for that first piece, we have y to the 18 over 42 power. And then we're going to come and do the same thing with that z. We put 35 over 42. So we have z to the 35 over 42. And we definitely want to simplify these here. 18 over 42, 6 goes into both of those numbers. So if we take 18 divided by 6, we get a 3 up top. 42 divided by 6, we get a 7. So y to the 3/7 is the same thing as 18 over 42. All I did there was simplify fractions. And now for z, we can divide both of these numbers by 7. 35 divided by 7 is 5. 42 divided by 7 gives you 6. Just make sure you simplify your fractions there. And that's all we can do for that problem. Now, number 12, I'm going to go ahead and show you the quick way of doing this versus the long way. The long way would be multiplying these two things together. It's not wrong if you did that because you can multiply these two insides together since they're both cube roots. However, you're going to get a big number, and plus you're missing a key shortcut here. Look at each piece separate. The cube root of 27, we've done that several times now in the course, and I think we've actually done a 27 at some point in this review. The cube root of 27 is going to be 3. So really, we're pulling that 27 all the way out of the house because remember 27 is 3 times 3 times 3, and you're looking for groups of 3. So that's where that 3 comes from. And now we can also pull out a group of m's because we're looking for groups of 3, and that's exactly what we have right there. So we have 3m. The cube root of 27m cubed is 3m. There is no need for a house back in that first radical here. And the same thing is going to happen to this house as well. The cube root of 125, if we take 5 times 5 times 5, we can pull out that group of 5s. So there's that 5, that one group of 5s that we're pulling out. And the cube root of m cubed is going to be m. Notice we have no houses left over, so we take 3 times 5, we get 15, m times m, don't forget to add those understood ones, so we have m squared. That's our final answer right there. Now again, the long way, it wouldn't have been wrong, but you could have multiplied these two numbers together and then try to break that number down, but I guarantee you end up getting 15m squared when it's all said and done. So look for shortcuts when you can. All right, number 13. Let me get a swallow drink. Number 13, use the quotient rule to divide and simplify. We can write this all as one house. So I'm going to do that just to remind you that you can take, as long as these indexes are the same, square root, you can put it inside of one big house. Therefore, we have the square root of 20. And now we want to simplify this. So let's break 20 up. 20 breaks up into 4 times 5. 4 breaks up into 2 times 2. Bringing our 5 down, and we're looking for pairs. Remember, we're taking the square root. So we have a pair of 2's. So therefore, we write down that pair one time. Whatever pair we pull out, we write it down one time on the outside of the house. And then whatever you did not circle, you put it back inside of the house. So 2 square roots of 5 is going to be that answer right there. And I tell you what, since we're making good progress on this review, I'm going to go to the calculator just to check and remind you, when you have a bunch of numbers flying around, it's a good idea to check your work if you have time. So let's take the square root of 100 and let's divide by the square root of 5. Now what I'm doing is I'm just typing in exactly what we had right here. And we get that right there, 4 point blah, blah, blah. And now let's type in our final answer, 2 square roots of 5. Just like that. And notice we get that exact same decimal that we got back here when we first typed this in. All right. Now, simplify the radical expression. Assume that all variables represent positive real numbers. So there's no need to worry about absolute value here. Besides, we're taking a cube root anyway, so there's no need to worry about absolute values whenever we take an odd root. But anyway, p to the 11th. Now, I'll tell you what, I'm going to write down 11 p's. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're trying to pull out groups of 3. So there's one group, there's 2 groups, and there's 3 groups. So therefore we have p cubed because we pulled out 1, 2, 3 groups. What do we have left over? That's what goes back inside of the house. We have a p and another p left over, so we need to put a p squared back on the inside. And do not forget the original index. This was a cube root right here. So don't forget that in your final answer. Now the shortcut to this is still to ask yourself, how many times does 3 go into 11? 3 goes into 11 3 times with a remainder of 2. So that's another way of looking at that. On to number 15. Find the distance between the pair of points. The distance formula is this. The square root of x2 minus x1 squared plus y2 minus y1 all squared. And that's what the distance is equal to. So I write d equals. In this particular problem, what we'll go ahead and do, the best way to do this is just, this is the first point you see, so let's label that x1, comma, y1. Therefore, and this is the second point that we have, so we'll label this x2, y2. These 1s and these 2s, as I've mentioned in class, that just means the first x value, the first y value, and that's what we have right there, and the same goes for this. So now let's go ahead and plug this stuff in and let's start to simplify. Alright, so we got x2 minus x1 squared. Take these two x values and subtract them. So x2 is negative 7 minus x1, which is 6, and we square it, plus y2, that's going to be this negative 5, minus y1, which is 1, and then we square that. And then I'll just continue on over here to the side. We have the square root. Negative 7 minus 6, that's negative 13. Just watch your signs there. And we're going to square that. Plus negative 5 minus 1, that's negative 6. And we're squaring that as well. 13, or negative 13 squared. It's still going to be a positive number though. Negative 13 times negative 13 is 169. Plus 6 squared is 36. And if you add 169 and 36, we get the square root of 205. All right, now from here, we have to ask ourselves, okay, can we simplify this thing? The distance between these 2 points, I've mentioned this in class. I'm not going to go off and graph these 2 dots on a number line or on a coordinate plane and do the Pythagorean Theorem, but I have showed you that. But we're trying to find the distance between these 2 points on a coordinate system. 205, if we try to break 205 up, that's going to be 5 times 41. Both of these numbers are prime, so we cannot simplify this at all. I know back here earlier, when we had the square root of 20, we broke that 20 up and we simplified that radical. We cannot do this with 205. There are no pairs to pull out, so that is your final answer. If it did say, and I think in the homework it did give you an example where you had to round to the nearest tenth, well, you'd go to your calculator and you'd find the square root of 205 and you'd round it to the nearest tenth or whatever it did ask you to round to. But we'll just leave it in radical form for right now. Now, number 16, add or subtract, assume all variables represent positive real numbers. So in order to add these 2 radicals, remember, to add or subtract them, you must have like radicals. These 2 things do not add up. You don't want to take 3 minus 6 and say negative 3, and 6 minus 24 and say square root of negative 18. That is not correct at all. Don't do that. We have to have the same radical. We do have the same index, but our insides do not match up. So trying to break 6 up, if you try to break 6 up, it'll be 2 times 3. There is nothing you can pull out of that house, so we're just going to leave 3 square root of 6. However, for the square root of 24, let's not forget, though, that we already had this negative 6. So I'm going to go ahead and bring that down, or subtract 6. Either way you want to look at that. And now breaking up this 24. 24 you can break up into 8 times 3, 8, and we'll break up into 2 times 2 times 2, and then let's bring that 3 down. So we're looking for pairs because we have a square root, understood 2 right there. So there's a pair. Let's write it down on the outside, and we would multiply it by what's already out there. So there's that group of 2's that I pulled out. We multiply that by -6 in a minute. And then look at what you have left. You have a 2 and a 3 left. We put that back on the inside of the house and we multiply those two numbers together to get 6. So therefore from here we have 3 square root of 6, just bringing that down, minus 12. Make sure you multiply there. And then we have the square root of 6. Now we do have like radicals, so we can take 3 subtract 12, that gives us -9, and then we just bring that square root of 6 along for the ride. Combining like terms, combining like radicals, that means the same thing in this case. So we have time. Let's go to the calculator. Let's check our work since we don't have any variables to worry about. And let's see if we get the same funky decimal for both of these. 3 square root of 6 minus 6 square root of 24. We get that. -22 point blah blah blah. And now let's see if we get the same thing for this right here. -9 square root of 6. And as you can see there, we get the same exact decimal. So we're good. We've simplified this down, and let's go on to number 17. Find the perimeter of the triangle, and then we need to simplify. So what we're doing is we're going to take each one of these radicals, the square root of 12, the square root of 108, and the square root of 112. And we're going to add these together to find the perimeter. That's what we want to do in this example. So copying these down, we want to add them together. And that's what's going to give us our perimeter. So this will be equal to P. All right, let's take each one of these and let's break them up. 12 we can break up into 4 times 3. 4 we can break up into 2 times 2, and I'm going to bring that 3 down. 108, if you know your times tables, 9 times 12 is 108. 9 is going to be 3 times 3, and notice, look, we just broke apart 12, so we know 12 is going to end up giving us these 3 numbers right here. 2 times 2 times 3. All right, 112. Let's take 112. Let's see. Something that goes into 112. I know 2 goes into it. We'll go ahead and do 2. 2 times 56. 56 you can break up into 2 times 28. 28, I'm going to go ahead and skip a few steps here. 28 is 7 times 4. So therefore we can just take 7 times 2 times 2 because that's 7 times 4. Bringing down our other numbers. So therefore, what do we have here? Let's pull out some pairs. A pair of 2's is what we can pull out of this square root of 12. So we have 2 square root of 3. I'm putting that 3 back inside of the house. Looking at our next group, bringing that plus down, we can pull out a group of 3's and a group of 2's. When we pull each one of these out one time and multiply them, we get 6. There's a group of 3's and there's one group of 2's. 3 times 2 gives you 6. But we also have a 3 left over inside of that house. And then the 112, we can pull out one group of 2's, two group of 2's. So therefore we have plus 4. And this one has a square root of 7 left over. And this is equal to P. So be careful here. Don't think there's no need to second guess yourself. You didn't do this wrong as long as it looks like this. The only thing we can combine, however, is going to be these two right here. Those are the like radicals. So 2 plus 6 gives you 8 square root of 3. And then this 4 square root of 7, we just bring it down. And now just don't forget that this does represent meters. So we have 8 square root of 3 plus 4 square root of 7 meters is going to be our perimeter. And that's it. That's all we can do for that one. And, you know, probably what you're going to be doing, you might second guess yourself on how we broke up this 112. But just to show you that this is correct. 2 ways to check our work here. First of all, if you were using a calculator to break up that 112, we had 2 times 2 times 7 times 2 times 2. That should give us 112. 2 times 2 times 7 times 2 times 2. Notice we get the 112, so we're good there. And now let's go back up here and let's type this in and see what kind of weird decimal we get. The square root of 12 plus the square root of 108 plus the square root of 112. All right, so we get 24 point blah, blah, blah. And let's see if we get that exact same decimal down here. And if we did, that means this is totally simplified and we did our work right. 8 square root of 3 plus 4 square root of 7. Notice you get that exact same decimal. So we're good to go. Yep, they do match up. All right, on to the next problem. Number 18 over here on the side. Find the area. Remember, the area is going to be length times width for a rectangle. So area equals, take your length, 4 square root of 18, times your width, which is the square root of 8. And there's two approaches that you can take here. Hang on one second, phone's ringing. All right, so the two approaches that you can take, you can multiply these two houses together. So I'm going to go ahead and do that right now. 4 times an understood 1, that's still going to be 4. Square root of 18 times square root of 8. If you take 18 times 8, you get the square root of 144. If you didn't notice this, square root of 144 is a nice number. So we have 4 times 12 because the square root of 144 is 12. And therefore the area here, 4 times 12, will be 48 square feet. That's your final answer to that problem. A second approach, which would actually end up being quite a bit longer, I'm going to show it to you anyway since I mentioned it. The 4 square root of 18, and we're multiplying by the square root of 8. Now again, this is just an alternative technique. I do not recommend doing this one, but sometimes this might be the better way. This was real nice. This worked out real nice to the point where we got a nice number. We're going to get a nice number down here, but it's going to be a little bit more work. Some of you, when you were approaching this problem, you might have went ahead and broke the 18 up. The 18 will be 9 times 2, which is going to be 3 times 3 times 2. So you can pull out a group of 3's, and there's already a 4 already out there. So we have area equals that 4 times, there's that group of 3's, so we're going to write it down one time, and then we have the square root of 2 left over. 8, we've done this several times. 8 is going to be 2 times 2 times 2. So we can pull out a group of 2's. So we multiply times that 2, and then we still have a square root of 2 left to put back inside of the house. So now we're looking at 12 square root of 2 times 2 square root of 2. 12 times 2, those two numbers on the outside we multiply together. We get 24. And then remember your shortcut for square root of 2 times square root of 2, that is 2. And notice 24 times 2 does give you that same 48 square feet for the area. For both of these problems, since we are kind of dealing with the real world, so to speak, perimeter and rectangle, make sure to come back and put a sentence. You know, here you can say the perimeter is 8 square root of 3 plus 4 square root of 7 meters. So just a reminder here for these two problems, don't forget a complete sentence. For the sake of this video, I'm just going to zoom or cross that out for right now so we can get through these problems quickly. All right, number 19. Rationalize the denominator. Assume that all variables represent positive real numbers. So since we have positive real numbers, if we ever took an even root, we don't have to worry about the absolute value. No variables here, so let's go ahead and jump straight into it. Rationalizing the denominator. We want to get rid of this radical, and to do that, we make this radical show up this many times. The index is 3, so we need to make this show up 3 times at the bottom. So notice we do have the cube root of 11 showing up 3 times at the bottom, but for every time we put it at the bottom, we must put it at the top as well. So we have the cube root of 11 at the top. And now your shortcut to this, cube root of 11 times cube root of 11 times cube root of 11, the house burns down. I've mentioned this several times. Cube root of 11 times cube root of 11 times the cube root of 11 is going to be that, just 11. The house burns down. Up top up here, the 7, we cannot multiply it times these numbers, so we have 7, and then we have the cube root of 122. Excuse me, 121. What am I doing? So it's the cube root of 121. And that's all we can do with that one. You might think that 121 breaks up, but 121 is 11 times 11, and we can't break that up anymore. So we don't have anything that occurs in groups of 3. So that's all we can do. We've rationalized it. We've gotten rid of the radical at the bottom. Now number 20, we have to work with a conjugate here because we have 2 terms at the bottom. In this example we had up here, it was just 1 term, so we just make it show up that many times. But since we have 2 terms in this problem, we must use the conjugate. So we have the square root of x minus 8, and that's at the top and the bottom. And I'm just going to be extra careful here, make sure that house doesn't go too far. And when you multiply these, up top, I'm not even going to worry about distributing that -9 in there. I'm just going to go ahead and write over here -9 times the square root of x minus 8. However, at the bottom, we have to be careful here. We do need to do the FOIL method. Square root of x times square root of x, shortcut, that gives you x. Remember that, I've mentioned that several times. The square root of something times the square root of that same thing, the house burns down, so we're left with just x there. Square root of x times -8, that is -8 square root of x. 8 times the square root of x, that's going to be plus 8 square root of x. And then multiplying this last piece here, 8 times -8, that is -64. And I notice here by doing the conjugate, these 2 middle pieces here will cancel out. So what we're left with up top is just -9 square root of x minus 8. All over x minus 64. Notice we no longer have any radicals left at the bottom. Everything looks nice. There's nothing to cancel out, so we're done with this problem. We have rationalized this. So be careful, you know, when you have 1 term versus having 2 terms. When to use the conjugate and when not to use the conjugate. All right. 21, the maximum number of volts E that can be placed across a resistor is given by the formula E equals the square root of PR, where P is the number of watts of power that the resistor can absorb and R is the resistance of the resistor in ohms. If a 1/8 watt resistor has a resistance of 1152 ohms, find the largest number of volts of electricity that could be placed across the resistor. A lot of electrical work here, but we're trying to find the largest number of volts of electricity. Notice that E represents the maximum number of volts. So we're trying to find E. That's what it says up here. E is the maximum number of volts, and that's what we're trying to find. So we have E equals the square root, and now it's just a matter of plugging and chugging. P is the number of watts. Notice right here we have a 1/8 watt resistor, so we have 1/8, that's our P. Times our R. R is the resistance in ohms. Well, notice we have 1152 ohms. So we just multiply those 2 numbers together. And I tell you what, we'll go to the calculator to do that. 1/8 times 1152, and you get 144. Notice I brought the house down. I brought that square root down, and this is a very nice number. We've already seen this once in this video. Therefore, we can say the square root of 144 is 12. So now I will go ahead and write a sentence out here, though, even though I skipped it in the last 2 problems. The largest number of volts of electricity that can be placed across the resistor is 12 volts. Something like that will be just fine. Give me a complete sentence since we're dealing with a real world problem. Just don't say 12. All right. 22. A balloon is secured to rope that is staked to the ground. So this is our rope, and the balloon's up here. A breeze blows the balloon so that the rope is taut, while the balloon is directly above a flagpole that is 20 feet from where the rope is staked down. So, and we want to find the length of the rope if the altitude of the balloon is 80 feet. What we're looking at is a right triangle. Tell you what, so we got this distance here. That distance right there is 20 because it says the flagpole is 20 feet from where the rope is staked down. There's the flagpole, there's where the rope is staked down, so we have 20 feet right there. Find the length of the rope, so we're trying to find this, I'll call it C. That's the length of our rope. And now we have one more piece as well. We have the height of the balloon, because it says the altitude of the balloon is 80 feet, so we have an 80 right here, and we want to find the length of the rope. So what we need to do here is a squared plus b squared equals c squared, the Pythagorean theorem, because we do have a right triangle. We can call this a and call that b. Make sure your hypotenuse is on the other side of the equation. So a squared plus b squared equals c squared. We don't know what c is, but we do know that 20 is a and 80 is b. So 20 squared, that's going to be 400. 80 squared, that is going to be, not 16, it's going to be 400 plus 6,400 is equal to c squared. Adding 400 plus 6,400, we get 6,800 is equal to c squared. And let's see, that's not going to be a nice number. The square root of 6,800. Since we're dealing with a real world problem, it doesn't say this, but I'll remind you in class, we have to take the square root of both sides to get c by itself. So the square root of 6,800, I'm going to round to the nearest foot. 82 is approximately equal to c. And you can just go to the calculator to get that. What I did here is I took the square root of 6,800, and it's around 82 feet in this case. The reason why I wanted to go ahead and get an approximation is because we're talking about a real world problem. And notice, I mean, we have numbers that are relatively easy to work with, 20 and 80, so I wouldn't want to leave it in a square root form. So a complete sentence, depending on what I did ask you to round to, since we rounded to the nearest foot, the length of the rope is approximately, notice I'm using that word approximately, 82 feet. And there's our complete sentence for that problem. All right, on to number 22. Use the quadratic formula to solve the equation x minus 9 times x minus 1 equals 22. We have to use the quadratic formula according to the instructions, so we have to make it look like this. Ax squared plus bx plus c is equal to 0. It looks nothing like that at the moment, but we'll get there eventually. Let's take x times x. We have x squared. Speeding up this process a little bit. That's minus 1x and that's minus 9x, so therefore we have minus 10x when we combine those two things that I just said. And then the negative 9 times the negative 1, that's positive 9. This is equal to 22. It's starting to look like this, but remember we have to force a 0, so let's move that 22 over. So subtracting 22 from both sides. Therefore we get x squared minus 10x, and then 9 minus 22, just watch your signs there, you get negative 13. And this is equal to 0. Now you might try to factor this, but it won't factor because there are no two numbers that multiply to give you negative 13 and add to give you negative 10. So we'll use the quadratic formula here. Notice now we do have it in the form ax squared plus bx plus c equals 0. A is equal to 1, b is equal to negative 10, and c is equal to negative 13. Just to remind you of what the quadratic formula is, it's going to be x equals negative b plus or minus the square root of b squared minus 4ac. And this entire thing, just this side, don't go putting the whole fraction bar across the equals now, I've mentioned that, but it's all over 2a. So therefore, x equals, we're trying to solve for x. X equals, let's start plugging and chugging. Negative b, we take the opposite of this, that's going to be 10. Because b was negative 10, we take the opposite, so it's going to be positive 10. Plus or minus the square root. I'm going to go ahead and skip a few steps here. B squared, take this number and square it. Negative 10 times negative 10 is 100. Minus 4 times a, which is 1, times a negative 13. All over 2a. So 2 times 1 Cleaning this up, what we have is x is equal to 10 plus or minus the square root. Now, be careful here. This becomes 100 plus, and then we take 4 times 13. 4 times 13, that's going to be 52. And this is all over 2. Now, I did mention in class, some of you might just go ahead and type this in right here, and you might go ahead and get the 152 on the inside of the house, which is totally fine with me. We got x equals 10 plus or minus the square root of 152 over 2. Now, this might be your final answer. It might not be. It depends on how this 152 breaks up, if it does break up at all. So let's go over here to the side, and let's see if 152 will in fact break up. So if we take 152 and divide it by 2, we get 76. So yes, it is going to break up because we can take 76 divided by 2 and we get 38. And then the 38, if you divide it by 2, you end up getting 19. So notice we can pull out a group of 2's, and we're still going to have some numbers left over. So what we're looking at is x equals 10 plus or minus, we can pull out that group of 2, so we have a 2. Square root, we have a 2 and a 19. They multiply back to give you that 38 on the inside of the house, and this is all over 2. Now remember, you do not want to take just the 10 divided by 2. That 10 is not in a house, that 2 is not in a house, so we need to divide both of those numbers by 2. So our final answer that we're looking at here is going to be x equals 5. 10 divided by 2 is 5. Plus or minus, that becomes an understood 1. So how about we just go ahead and write the square root of 38. That's our final answer, totally simplified. And yeah, let's move on to the next problem. 24. The revenue for a small company is given by the quadratic function r of t is equal to 11t squared plus 18t plus 860, where t is the number of years since 1998. That t represents the number of years since 1998. And r of t is in thousands of dollars. So the r of t is thousands of dollars of revenue. If this trend continues, find the year after 1998 in which the company's revenue will be 1,225,000. So okay, since the revenue is represented in thousands, we're really just going to plug this into that r of t. 1,225,000 thousands. I know it sounds funny, but since the revenue is already in thousands of dollars, we have this number, and that's written in thousands as well. So we plug in this number, 1,225,000, so to speak, is equal to 11t squared plus 18t, and then plus 860. And now we want to find or solve for t, because it does say we want to find the year. Find the year after 1998 in which the company's revenue will be that amount. So let's round to the nearest whole year. What we have to do here is solve this quadratic. Notice this looks kind of similar. It's getting close to looking like this. We need it to look like 0 equals ax squared plus bx plus c, but instead of x's we have t's here. It's starting to look like this. We have to move that 1225 over here. So let's subtract that 1225 from both sides. Notice I am putting it beneath the constant. So now we do have 0 is equal to 11t squared plus 18t. And just to speed up this process, to the calculator, 860 minus 1225, that's negative 365. Now, I'm going to go to the calculator for this one. I should have done that in the last example, but it'll be okay. The reason why I'm going to go straight to the calculator is because we want to go ahead and round this to the nearest whole year. I'm going to still take it step by step, so to speak, just to get you a little comfortable with typing this into the TI-30X, or if you have a TI-84, grab that, but I'm going to use just the regular scientific. So A is equal to 11, B is equal to 18, and C is equal to negative 365. Now the quadratic formula was on the last page. I'll tell you what, I'll just go over here and copy it. probably by this point you've done so many in the homework that you have this memorized, which is a good thing because you definitely will use this in other math courses. So let's plug and chug. X equals negative b, so we have negative 18, plus or minus, don't forget that, the square root of b squared, so we have 18 squared minus 4 times, I'll tell you what, I'm going to use parentheses. You can use those as well, I mentioned that in class, times negative 365. And this is all over 2a, so 2 times 11. All right, so let's clean this up a little bit. We have x equals negative 18. Going to the calculator, plus or minus the square root. I'm going to figure out what that number is on the inside of that house. So we got 18 squared minus 4 times 11 times negative 365. So we get 16,384 on the inside of there. And this is all over 22. Now we're going to get two answers here, and I'm going to go ahead and go straight to the calculator to finish this off. But we're going to get two answers. The reason why, because we have the plus and we have the minus. So there are two solutions here. We only want to deal with the positive one, because I guarantee you we're going to get a positive one and a negative one. So typing this in. All right, I'm going to type in this entire numerator, and I'm going to go ahead and do the plus one first. So we have negative 18 plus the square root of 16,384. So that's our numerator. Oh, that's nice. Divide. I didn't know we were going to get a nice number. Divide that by 22, we get 5. Okay, so it's not an approximation here. It's an exact. X is equal to 5. Now let's look at the other answer though, because notice, like I said, we're going to get two answers. Negative 18 plus, and now we're going to have the negative 18 minus that square root. Notice we do have a negative number here, and if we divide that by 22, we get a weird answer, and it's a negative answer. So the one that we want, we don't want that one. We don't want that negative 6.6. This is the one that we want, but now let's go back and reread the question. It says round to the nearest whole year. Well, it is a whole year anyway. But if this trend continues, find the year after 1998. Now notice that t is the number of years since 1998. So if t is equal to 5, all we want to do here is take 1998 and add 5 to it. Therefore, we're going to get the year 2003. Now, make sure we go back and leave this in a complete sentence. So I'll come back up to the top just to make sure I'm reading this off right as well. Let's see. The company's revenue will be 1,225,000 in the year, or let's just say in 2003. Now remember our answer, that is 5 years after 2008. Now you don't have to include that stuff in parentheses in your answer, but since we got an answer of 5, 2003 will be 5 years, not after 2008, it should be after 1998. All right. I'll get this down here to clean it up. So don't forget your complete sentences for these answers. All right, moving on. Last problem. The hypotenuse of a right triangle is 9 feet long. So we have a right triangle. The hypotenuse, that's going to be this guy right here. One leg of the triangle is 5 feet longer than the other leg. So let's call this leg L. Let's call it X, because I like writing X is better than L's. That way we don't confuse them with ones. So if this one's X, it says that one triangle is 5 feet longer, or one leg of the triangle is 5 feet longer than the other leg. So if this leg is X, this one right here can be X plus 5. Whatever this one is, this one right here is going to be 5 feet longer. Find the perimeter of the triangle. So what we need to do here, we got to find what X is first. And once we find what X is, we can come back and plug it in and we can find the distance all the way around this triangle. Because remember, the perimeter is the distance around a shape. So we have to set up Pythagorean Theorem. This is our A, this is our B, this is our C. So A squared is going to be X squared plus, be careful with the B squared here. It's going to be X plus 5 in parentheses squared. And this is equal to C squared, which is 9 squared. Now I'm just going to scribble in a few things here to speed up this process. What we have, X plus 5 squared, recall that is going to be X plus 5 times X plus 5. Just to speed up that, I don't want to do all that FOIL method here. So bringing down that first X squared, we have X squared plus, doing this one right here in red, you're going to have X squared plus 10X, make sure you combine like terms, plus 25. And over here on the right hand side we have 81, because 9 squared is 81. Cleaning this up, we have 2X squared, combining like terms up top, plus 10X plus 25 is equal to 81. And then from here, let's force a 0. So if we force a 0, subtract that 81 from both sides. Trying to do the quadratic formula perhaps. So we have 2x squared plus 10x, and then 25 minus 81, we get negative 56. This is equal to 0. Now I've mentioned this too. You can go straight to the quadratic formula if you want to. But notice we can divide everything by 2. If we divide everything by 2, it just makes life a little bit easier to work, not life, but it makes this problem a little bit easier to work with because your numbers are smaller. Dividing by 2 here, we get x squared. Dividing by 2 here, we get plus 5x. And dividing by 2 here, 56 divided by 2, that's going to be minus 28. This is equal to 0. All right, so from here, that won't factor because there are no two numbers that multiply to give you 28 and add to give you 5. So unfortunately, we're going to get a crazy decimal. I was thinking we'd get a nice number, but we're not going to. All right, so let's go ahead and do the quadratic formula. A is equal to 1, B is equal to 5, and C is equal to negative 28. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in, so negative b, that's going to be negative 5 plus or minus the square root of b squared, so I'm going to go ahead and say 25, minus 4 times 1 times a negative 28. Notice I've done the parentheses sometimes and sometimes I've used the dots. It doesn't really matter as long as you're careful with your signs. And this is all over 2 times a, which is just going to be 2. All right, so let's go straight to the calculator. Let's get this number inside of here. Now, it does not say to round this thing. That's something I wish this test was a little bit more, it doesn't say leave your answer in simplest radical form. It doesn't say to round it. I tell you what I'm going to do, since I'm making this video, I'm going to say we can round this answer because it's going to sound nice just to go ahead and say, the perimeter is going to be 30.2 feet versus having a radical around here. So what we'll go ahead and do is we'll go ahead and round this answer. Oh, okay, actually, I'll tell you what, we'll do an exact answer and we'll do a rounded answer. That way we can make both sides of the family happy. All right. So going to the calculator, I'm going to go ahead and work out the inside of that radical. 25 minus 4 times 1 times negative 28. So 25 times, 25 minus 4 times 1 times negative 28. So inside of the house, we get the square root of 137. So we have negative 5 plus or minus the square root of 137 all over 2. And that's actually as far as we can go with that. That is the exact answer for x. Now, seeing it like that, I definitely want to just go ahead and round this thing. I know I said I was going to do it both ways, but it's going to be more trouble than what it's worth, to be quite honest with you. So let's go ahead and get an approximation for this answer. And the reason why it's going to be more trouble than what it's worth because you have a fraction, nothing simplifies. I mean, 137, I think that's a prime number, 137. Yeah, I think it is. All right, so let's go ahead and get an approximation. Negative 5 plus the square root of 137. Let's go ahead and figure out what that numerator is. And now we come back and divide it by 2. So the approximation, let's say 3.4. It's approximately 3.4. Now the reason why I don't want to worry about the other one, I'll show it to you real quick though. If we take the -5 and subtract the square root of 137 and then come back and divide that by 2, we don't want negative answers for x because there's no such thing as having a negative length on a triangle. So our approximation was 3.4. So if we plug in 3.4 there, that leg is going to be 3.4. This one right here is going to be approximately 8.4. So the perimeter is going to be approximately 3.4 plus, we get 8.4 here when we plugged in 3.4 there. And then plus that 9. And I wrote 3.4, but I just said 8.4. So therefore, we get an approximation. That's going to be what? 8, 11, 20, 20.8. So 20.8 feet. So a complete sentence. I will remind you on the test to round these. And like I said, it was more trouble than what it's worth to leave it like that and plug it back in and try to find the perimeter. There will be times when you will have to do that, but not here in the DMA 80. Let's not worry about that right now. The perimeter of the triangle is approximately 20.8 feet. All right. And what was that? That was number 25, wasn't it? Yeah, so there it is, the radical, rational exponents, cube roots, square roots, rationalizing, all that stuff all into one. If you know a good chunk of this material, you'll do just fine on the module exam. And that is it for this video. Hope it helped.